Hydrocarbon compounds. Organic chemistry. Original definition. Living organisms are the only ones capable of forming carbon compounds. This is what people believed a long time ago. Today's definition is that living organisms aren't the only ones capable of forming carbon compounds. They can also be synthesized from inorganic compounds. Why is carbon so special? Carbon has 4 valence electrons leading to 4 covalent bonds. Why is the simplest organic compound called hydrocarbon? And basically, it's because it contains carbon and hydrogen atoms. The uniqueness of carbon comes from the fact that it can bond to itself. Carbon atoms can form very long chains. In this picture, carbon is in color black. What sort of bond does carbon do with hydrogen or carbon itself? And is covalent bonding. But what does covalent bonding mean? And that is share electrons. Alkanes. Alkanes are hydrocarbons, carbon-carbon or carbon-hydrogen bondings with single covalent bonds. There are 2 types of alkanes: the straight chain and branched chain. Straight chain alkanes. Naming. Straight chain alkanes are an example of homologous series, where there is a constant increment of change in the molecular formula. In here we can see that for 1 carbon we will call it methane, 2 ethane, 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, and 10 decane. The straight chain alkanes. Drawing. Alkanes can be drawn in different ways. The most important are structural formula, condensed formula, and line angle formula. Structural formula. Use dashes to connect carbon and hydrogen atoms. The example in here is the molecule of propane. That is 3 carbons and 8 hydrogens. The structural formula will be this one. Condensed formula. You add the atoms that repeat in the carbon atom bonded to it. An example in the same is propane, and the condensed formula in here will be CH3-CH2-CH3. Line angle formula. Carbon atoms are located at each intersection and at the end of lines. Hydrogen atoms are understood. This is omitted. Back again with propane, the line angle formula will be this one. Now is your time. Draw the structural, condensed, and line angle formula for the next alkanes, butane and hexane. Stop the video, and when you are done, play it back so you can compare your answers. Good luck. Branch chain alkanes. Naming. Branch chain alkanes and straight chain alkanes, where a hydrogen atom or more are substituted by an atom or group of atoms, and is called substituents. In here we can see, instead of having 3 hydrogens, the long chain, it has 3 substituents. If the substituents are hydrocarbons, then they're called alkyl group. In case that is with 1 carbon instead of methane, is called methyl. So, can you deduct the other from 2 to 5 carbons? When naming alkyl groups, if the carbon chain is straight, use the root of the hydrocarbon prefix and add the suffix YL. For methane is methyl. For ethane will be ethyl, propane, propyl, butane, butyl, and finally pentane, pentyl. There are special cases. If in propane is bonded not to the end of the chain but in the middle of the chain, is called isopropyl, and it's a similar case for isobutyl. There are several rules that you have to follow. First, find the longest chain, which is the parent chain, and number the carbons starting at the carbon where the alkyl groups are nearer to. This will give you the parent chain. In these examples, we can see that there are 5 carbons, so the name will be pentane. Second, locate alkyl group substituents and add the number of their position as a prefix to its name. So in here we have 3 substituents and they're methyl, so we're going to call it 2-methyl, 2-methyl, 4-methyl. In the second example, is bonded to the third carbon, so it's 3-ethyl. 3. List the names of alkyl group substituents in alphabetic order. If the same group repeats, separate its number with a comma and locate it as a prefix to the parent chain. In the first example, we will have 2,2,4 trimethyl pentane. In the second example, it will be 3-ethyl pentane. Now is your time. Name the next branch chain alkanes. Stop the video, and when you're done, play it back so you can compare your answers. Good luck. Properties of alkanes. Density. The density of alkanes is less than water. That's why it floats. Solubility. Alkanes are water insoluble, so even though you mix it, it will never mix with water. Boiling point. It increases with the molecular size, so that means that the more carbons you have, the bigger the boiling point will be. And finally, melting point. When you freeze up, when you cool it down, you will form what is called crystal packing. Thank you for watching.